Well, good evening. In the last class, we have seen what is meant by a boiler and what are the functions of boiler. After that, we have seen what is the classification of boiler. So, boiler is basically a device in which the water is converted into steam. So, in order to do this task, heat has to be supplied to the water. So, here this heat is produced by some combustion process which is taking place in the combustion chamber. So this is also called as furnace. So in furnace, the fuel is burnt so that hot flue gases are formed, and these hot flue gases are in turn transfer their heat to the water surrounding it, and hence the water is converted into steam. So this is basically function of any boiler. And there are different types of boilers based on different criteria, like based on the content inside the tubes. The boilers can be classified into fire tube boiler and water tube boiler. So if the content inside the tube means if the flue gases or the hot gases flows through the pipes and water surrounding, if the water is surrounding the pipes which carries hot gases, then such boilers are known as fire tube boilers. And if water is flowing through the pipes and hot gases surrounds these pipes, then such is called as a water tube boiler. And we shall see the comparison or the differences between these two types of boilers in this session later. Before that, we shall discuss different boilers, various important boilers are there. So we shall discuss one by one. So the first one is the Cochran boiler. This Cochran boiler, see here, you can see the image of the Cochran boiler in this slide. Okay, so by observing this, simply you can say that by observing the axis of the boiler, you can understand that it is a vertical boiler since its axis is vertical. If the axis is horizontal, that is a horizontal boiler, but here it looks like a vertical boiler. Let us see what is there inside. So this is basically a vertical and multi-tubular fire tube boiler. So this is a fire tube boiler. That means hot flue gases flow through the pipes and water surround this pipe so that there is a transfer of heat between the water and hot flue gases inside the tubes. And there will be a number of tubes which carries these flue gases. So that's why this is called as multi-tubular boiler. In some boilers, there will be a single tube. So that is called as single tube boiler, but here it is a multi-tube boiler. So if anybody asks you what is a Cochran boiler, means it is a vertical multi-tubular fire tube boiler. Hello. Okay, is it clear? వినిపిస్తుందా అన్నమాట? Respond. Am I audible?
Yes, sir.
Right. So this is basically a Cochran boiler. So this is the diagram. So we just observe this diagram and identify various parts in it. So this consists of basically an outer body, which is called as shell. Can you see my pointer? Arrow mark కనిపిస్తుందా? కనిపిస్తుందా లేదా ఎర్ర మార్క్?
Yes, sir.
Okay, right. So this is the shell of the boiler, which houses all the components of the boiler. And at the bottom, if you observe, some fire is being taking place. Okay, so this fire is nothing but the combustion process, so that some hot flue gases are formed. And here, this is the water space. So this entire shell is filled with water, and in between there are some tubes. So through these tubes, the hot flue gases flows. Okay? So this is basically the principle of boiler. So these hot flue gases, while flowing through these pipes, transfer their heat to the surrounding water, so that this water is converted into steam, and the steam so converted is collected at the top. So that's why here this is called as a fire tube boiler, as the flue gases passes through the pipes. Okay. Now let us see what are the various components and their functions. So this is another diagram of this Cochran boiler. Okay. So it consists of a shell. See, observe what is the shell. So this is the shell. A circle is rotating. So this is the outer one is called as shell, in which all the components are mounted. Here the blue color thing is the water. Okay. So this is a cylindrical shell with hemispherical top. See here, if you observe, the top is hemispherical in shape. So because it is used to collect the steam. As the steam is lighter in weight, it is collected at the top. So in order to accommodate enough or sufficient amount of steam, this is made in hemispherical shape, so that there will not be any resistance to the steam. Okay. And here, if you observe at the bottom, this is the firebox, which is located at this place. And here, the combustion takes place. That means the fuel is burned in the presence of oxygen. So in order to produce the oxygen, we need to supply air. See here, the air is being supplied from the bottom onto the combustion chamber, so that the fuel is burned in the presence of air, and hence the hot flue gases are formed. Okay, so this is the place of combustion, is also called as furnace or firebox. And here, if you observe, a grate means it is some mesh-like thing, which is used to send the ash produced downwards. See here at the bottom, there is a ash pit. So here the fuel, for example, the coal is burnt. So once the coal is completely burnt, it is converted into ash. So this ash falls into the ash pit through this grate. So grate is just like a mesh. You might have seen grates at your home. Home in the sense of ఇప్పుడు కుంపటి అంటారు, మీద ఎవరికైనా ఐడియా ఉందా? మీరు చూసారో లేదో. అందులో బొగ్గులు, అదే నథింగ్ బట్ కోల్ యూజ్ చేసి వంట చేసుకుంటాం, బొగ్గులు పొయ్యి అంటారు. ఓకే, ఆ బొగ్గులు పొయ్యి అది. దానిపైన ఒక చిన్న గ్రేట్ రౌండ్ గా ఉంటుంది, అది మీరు బహుశా చూసుంటారులేండి, మీరు చిన్నప్పుడు ఎప్పుడో ఉండేవి. ఓకే, సో దట్ ఈస్ గ్రేట్ త్రూ విచ్ ద యాష్ ఫ్లోస్ ఇన్ టు ద యాష్ పిట్. ఓకే, అండ్ దెన్ combustion chamber. So this is once again mentioned. So this is the combustion chamber, which is surrounded by water. See here, above the combustion chamber, the water is observed, so that the heat is transferred from the combustion chamber also to the water. Okay, well, and there are some tubes, smoke tubes. See, when the water flows, when the combustion gases flows through pipes, finally they have to leave into the atmosphere through chimney. So in order to send these gases to chimney, here you have some smoke tube or smoke box. So this smoke box is used to transfer the flue gases from the tubes to the chimney. The chimney is a device which is used to transfer the hot flue gases into the atmosphere at high altitudes. So they should not be left into the atmosphere at low altitudes. At the తక్కువ height లో వాడు పంపించామంటే it will cause pollution. అండ్ ఆల్సో మనకి ఈ బాయిలర్ లో డ్రాట్ అని ఉంటుంది. ఆ డ్రాట్ సరిపడా డ్రాట్ అంటే ప్రెజర్ డిఫరెన్స్. అంటే మనకి బాయిలర్ లోపలికి ఎయిర్ వెళ్ళాలి, అండ్ ఆఫ్టర్ దట్ ద ఫ్లూ గ్యాసెస్ అనేవి ఫ్లో అవ్వాలి, ఫైనల్ గా బయటకు వెళ్ళాలంటే దెర్ మస్ట్ బి సమ్ ప్రెజర్ డిఫరెన్స్ ఇన్ అండ్ అవుట్ సైడ్ ద బాయిలర్. సో ఇన్ ఆర్డర్ టు హ్యావ్ దిస్ ప్రెజర్ డిఫరెన్స్, దిస్ chimney is made at higher altitudes, so that at higher altitudes the pressure is low, and at the lower altitude the pressure is high. So that's why the pressure is high here and low here, so that the air flows from high pressure to low pressure. Okay, that is chimney. And after that, this is the furnace. So various key components or important components are mentioned. So furnace we have seen, and here if you observe on the side there is a water level indicator. So while producing steam, one has to monitor, or the operator has to monitor the quantity of water which is there inside the boiler. If the entire water is converted into steam, then water has to be refilled into the boiler. So in order to see the level, there is a water level indicator which shows the level of the water inside the boiler. So here it is placed. And then there is a pressure gauge. So the steam is produced at high pressures. As the steam continuously producing, the pressure of the steam high rises, and we must monitor the pressure. And say, for example, if you need 5 bar pressure, the steam at 5 bar pressure, then you must install a pressure gauge to know whether the steam has been pressure has been raised to 5 bar or not. And also it serves as an alarm, so that if the pressure is extremely high, there is a chances for explosion. So that's why the operator has to constantly monitor the pressure gauge. Okay, and there is one more valve called as safety valve. So here, this is the safety valve which releases the steam into atmosphere. So when the pressure is built up, see, when the pressure is extremely high, so that there is a chance of explosion. In such cases, the safety valve, see here, this is the safety valve. The safety valve is automatically opened, and some quantity of steam is sent out, so that the pressure again drops. So this is just similar to our pressure cooker waiter. So our pressure cooker is also a type of boiler. So there also you heat the water and steam is produced while cooking. Okay, and at the top you observe a weight. So this weight is nothing but a safety valve. Okay, so what happens when you cook food in a cooker? After some time, the steam is formed, and the pressure of the steam gradually rises. So as and when the pressure is raised, so that this pressure is enough to lift the safety valve. So as the downward force is more than that upward force applied by the valve, this valve rises and some quantity of steam is escaped into the atmosphere. అబ్జర్వ్ చేశారు ఎప్పుడైనా? ఇంట్లో విజిల్ వేస్తుంటుంది కుక్కర్. దాని అర్థం ఏంటి అంటే లోపల ఉన్న స్టీమ్ ప్రెజర్ పెరిగింది. ఆ ప్రెజర్ని లోపల తొక్కిపెట్టి ఉంచుతుంది. ఈ వెయిట్ అనేది చాలా ఎక్కువ ఉంటుంది. సో లోపల సఫిషియెంట్ ప్రెజర్ రాగానే అది ఆటోమేటిక్గా పైకి లిఫ్ట్ అవుతుంది. లిఫ్ట్ అయ్యి లోపల స్టీమ్ అనేది బయటకు వెళ్ళిపోతుంది. ఓకే, సో దిస్ ఇస్ ఎ safety device. In the same way, in industrial boilers also, there will be safety valve. And there is a blow-off cock. See here, this is nothing but rain valve. So if you want to clean the boiler, this blow-off cock is opened and the entire water is sent out if there is any. And then it is used to clean the boiler and remove the mud or sediments, if any, from the boiler. So this is about the blow-off cock. And feed check valve. Here, this is a stop valve. Feed check valve, here it is not shown. So this is used to control the flow of water which is entering into the boiler. The water has to be continuously supplied to the boiler. So it can be controlled by this feed check valve. Now let us see the working. So till now we have seen what are the various components. Now the working. So first of all, the fuel is burnt in this combustion chamber and hot gases are produced. Then these hot gases flows through the pipes. Here in this diagram, four tubes or pipes are observed. So while flowing through these pipes, the flue gases are, there is a transfer of heat between the flue gases inside the tubes and the surrounding water, so that the water gets heated and it is converted into steam. And once the steam is formed, it is lighter in weight, hence it moves upwards and it is collected in this hemispherical space. Okay, well, and after that, the required steam is tapped or taken out through this stop valve. So this is about the Cochran boiler. And if you see the advantages of boiler, it's very simple in design. It is a very compact or portable in design, and hence it occupies less space. And it is easy to operate. There are no complicated parts. It's just like a pressure cooker. So from the bottom you are applying heat, and the water is taken in the shell, and which is heated. Okay. And it is very cheap and economical to install and maintain. And heat transfer rate is also very good, so that it has higher efficiency. Coming on to the disadvantages, this is not suitable for heavy duty. So that means it cannot produce steam in high quantities or large quantities. So the quantity of steam produced is very less. So that's why this can be used for small scale applications. And the pressure is also limited. So if you want to produce, say, for example, 250 bar, it is not possible. Okay. And the output is limited. That means the quantity of steam produced is limited. Okay. Applications. So where do you use? Especially in industries, in small scale industries, for heating purposes, the Cochran boiler is used, and also in small thermal power plants to produce electricity, this Cochran boiler is used. It is also used for heating systems. So we have seen various applications of boilers, and that it can be used for heating the buildings, and also in marine applications. So some auxiliary systems has to be run by using the steam. In such cases, you can use this Cochran boiler. And it requires certain maintenance. So one has to regularly inspect the boiler for any leakages or wear and tear, and also all the sediments or scales which are formed due to the water. So if the water is not clean or impure, then some scales are formed and some sediments are deposited at the bottom, so that they have to be removed through Bobcock. And some safety checks are also has to be done regarding the boiler to avoid any unwanted things. And also the water has to be treated. Just now I already told you. If there is any scale, that means if the water is hard, the hardness of the water is more, then it forms scales on the tubes. So these, in order to prevent this, the water has to be treated first. Okay. So this is about the maintenance. So finally, this Cochran boiler is a versatile. That means it's a multi-purpose and an efficient boiler, and it can be used for small applications. So this is all about this one. Any doubts? So
Horizontal.
this Bobcock and Wilcox boiler is a horizontal boiler, because here if you observe, this is the drum of the boiler in which the water is taken and converted into steam. So the axis of the drum is horizontal. That's why this is a horizontal boiler. So what is this boiler? It is a type of water tube boiler. So previously we have seen that the Cochran boiler is a fire tube boiler, but here this is a water tube boiler. That means the water flows through the pipes, and the flue gases passes over these pipes. Then this is invented by George Herman Bobcock and Stephen Wilcox in the year 1867. So that's why this boiler is named after them. So Bobcock and Wilcox. And it can be used in power plants and industrial applications. It is a heavy duty boiler, unlike the Cochran boiler. Okay. So this is the textbook diagram of this Bobcock and Wilcox boiler. So what are various components? So it consists of a drum. So if you observe at the top, it is a drum which is used to store the water and also to collect the steam at its top. So at the bottom portion consists of water, and the steam is collected at the top. Okay. And there are two headers. So if you observe here, this pipe is called as a downtake header, and this is called as an uptake header. If you observe, there are some series of tubes which connects these two. So this is a downtake header. That means the water is taken downwards through this header, and this is the uptake header through which the steam is taken upwards. What happens is the water is taken from this downtake header into the tubes, And while flowing through these tubes, the water absorbs the heat. See here, this is the furnace. Okay, so that flue gases are flowing over these tubes. So when the water is flowing through the tubes, it absorbs the heat from the flue gases, and this water is converted into steam. And then the steam is once again sent into the drum through this uptake header. So that is, there are two types of headers. Okay, and then there are series of tubes which connects these two headers, uptake header and downtake header, through which the water flows. Okay, so the water is flowing through the tubes and it is converted into steam. And this is the furnace which is located at this place, at which the fuel is burnt and the combustion gases are produced, which are used to produce steam. Okay, so here this is the drum in which the steam is produced at its top, and usually this steam is wet or dry and saturated. So in order to heat this further, see here there is a tube. Observe this tube which is coming from the drum. Okay, so the steam then passes through this tube called a superheater. That means the steam already formed is passed through this tube, and during its passes through the tube, it is exposed to the hot gases, and hence it is further heated. See, hot gases are flowing in this path. Okay, so during its flow, it also passes over the superheated tube. That's why steam inside the superheater further gets heated up, and the steam is converted to superheated steam. And again, this is taken out here by using this top wall for different purposes. So that is the superheater. Okay. And here observe the flow of gases, the path of the gases. So here some baffles are placed in order to divert the gases. That means the gases have to be kept inside the boiler for longer times so that maximum amount of heat can be utilized. So in order to keep the gases for long time, these baffles are produced so that it takes some time to turn and come again in this way. So that's why if the crowd is high in temples, there are number of lines are arranged so that the crowd is uh, uh, allowed to wait in the lines. In the same way, these baffles serve the same purposes. Okay, right. And then the water flows. Now this is working. So till now we have seen various components. Now this is the working. So the water flows into the tubes by through this downward header, and then the furnace gases heats this water so that the water is converted into steam. So here there is an exchange of heat between the water which is inside the tubes and the flue gases surrounding the tubes so that the water is converted into steam, and finally it again reaches the drum through this uptake header, and this is collected at the top. Okay. Then the steam is then passed through the superheater where it is further heated so that superheated steam is formed. And this superheated steam has various applications which you have seen in the first chapter. Now let us come to the benefits or advantages of this Bobcock and Wilcox boiler. So it consists, basically it has a high thermal efficiency. That means for the quantity of heat supplied, the output is high. So it has high thermal efficiency and rapid steam generation. That means you can generate the steam quickly. Within less time, you can produce steam. And it's also compact and robust in design, and it is capable of handling high pressures. So unlike Cochran pressure, high pressures can be produced here. And also high temperature, that means superheated steam at high temperatures can be produced. And it is suitable for wide range of fuels. Any quality of fuel can be burnt inside the combustion chamber. There is no restriction for the quality. And coming on to the applications, so then this is basically useful in thermal power plants for producing electricity, and also in some industrial process we use this boiler where it requires steam, and marine propulsion systems, and hot water supply to the buildings. So this is all about Bobcock and Wilcox boiler. So any doubts in this? So till now we have seen two types of boilers. Cochran, which is a vertical pipe tube boiler, and Bobcock and Wilcox boiler, which is a horizontal water tube boiler. So by this time, you might have an idea of what is a pipe tube boiler and what is a water tube boiler. Okay. Now let us move to the next one. That is pipe tube and water tube boilers. So let us have a look. So in this session, we are going to discuss or we are going to compare the pipe tube boiler and the water tube boiler. So differences between these two. So if you observe the pipe tube boiler, the hot flue gases flow inside the tubes and water is surrounding the tubes. But in case of water tube boiler, water flows through the tube and hot flue gases surround the tubes. So this is the basic difference. And this pipe tube boiler is usually heavy in weight, whereas the water tube boiler is lighter in weight. And I have already told you that a pipe tube boiler, the furnace is located inside. So that's why it is called as internal pipe tube boiler or internal combustion boiler. But in case of water tube boiler, the furnace is not located inside the drum. See, in case of Cochran boiler, the furnace is inside the drum. But in case of Bobcock and Wilcox boiler, it is outside the drum. So that's why that is called as externally fired boiler. So this is internally fired, it's externally fired. And the pressure with the pipe tube boiler we get is maximum of 20 bar. But in case of water tube boilers, you can get pressures up to 100 bars. And the rate of steam generation is low in case of pipe tube boiler because the pressure is limited. But in case of water tube boilers, as the highest pressure is 100 bar, you can produce more quantity of steam. As the pressure is increased, the quantity can be increased. Now, the chances of explosion of fire in case of a pipe tube boiler is very less. But in case of water tube boiler, it is high. So why? The reason we will discuss while discussing the accessories of the boiler. Pipe tube boilers are safe against explosion, but water tube boilers are not that much safe against explosion. And coming on to the efficiency, these pipe tube boilers are less efficient and its efficiency around 70%, and water tube boilers are 90% efficient. Okay, and load fluctuations cannot be handled in pipe tube boiler. See, if the load is suddenly high, you have to produce more quantity of steam immediately, quickly. But it is not possible with pipe tube boiler, but it is possible with water tube boiler. And this pipe tube boiler is not suitable for large power plants, as I already have explained in case of Cochran boiler. And the water tube boiler is suitable for large power plants. Usually, this pipe tube boiler is simple in design, whereas the water tube boilers are complex in design. Okay, and the maintenance cost is also low for a pipe tube boiler as the design is simple, but the water tube boilers have huge maintenance cost. And the operator who operate the boilers, in case of pipe tube boilers, only less skilled operators are sufficient, but the water tube boilers requires huge or high skills for the operator part. Okay, so this is all about. There are some examples for a pipe tube boiler: Cochran boiler, furnace boiler, locomotive boiler, Vulcan boiler. So all these are examples for pipe tube boiler. And here Benson boiler, Lamont boiler, Bobcock and Wilcox boiler. So these are the examples for water tube boiler. You can expect a question, right? Any three examples for pipe tube boiler or any three examples for water tube boiler. Even you will get objective questions. So for example, Lamont boiler is a dash boiler, pipe tube or water tube, like that you will get. And pipe tube boiler requires more space. In case of water tube boiler requires less space. Okay, so this is all about boilers, pipe tube and water tube boilers.